I decided to record a video of number 22 from the problem set because this is a pretty tough skill here, and there's a detailed answer key, but sometimes it helps to have somebody kind of talk and explain through it. So I'll go as quickly as I can, but I know this is a little complicated stuff. So again, for context, if you haven't watched the class videos, we're trying to find the integral of this function, which is really used to help us find the area under this function, under this curve from 1 to 4. And the way we can do it is by splitting it up into an infinite amount of tiny little rectangles until we get exactly the area under the curve. So it's going to look like this, and really it's going to be the limit as n approaches infinity of the sum of f of xi and times delta x. So for our function, we first need what delta x is. Delta x is always b minus a over n. So 4 minus 1 is 3 over n. And xi is always whatever the first point is, or the first number. So it's 1 plus delta xi, so 3i over n. So once we have those, now we know, and I'm not going to write this part over and over again, but it does technically go first, but I just don't have enough room, and it would take way too long. The answer key does, though, every time, because I'm sure they just copied and pasted, cheaters. But I'm going to just keep going with that assumption that this is really what we're doing. So we have f of 1 plus 3i over n times 3 over n. So f of that means every time we see x, we put in this. So it's going to be 1 plus 3 over n squared minus 4x, so minus 4, 1 plus 3i over n plus 2. So this whole thing is f of x sub I, and then times 3 over n. So there's a lot of ways to go about this. We could, I think a lot of times the book just kind of pulls the 3 over n out front, which you're welcome to do, and then later kind of distribute out. Probably makes more sense. So I'm going to say 3 over n times, let's do this out, 1 plus 3 over n squared would be 1 plus 3i over n plus another 3i over n makes 6i over n plus 9i squared over n squared. So I'm really just foiling. Minus, now we're going to distribute this, minus 4 minus 12i over n plus 2. We can clean this up a little bit. So we have really 3 constants. And then we have these 2 that can go together, and then the 9i squared over n squared is going to be by itself. So we have 3 over n times, we have 1 minus 4 plus 2 is just going to make negative 1. And then 6in, so I'll say plus 6i over n minus 12i over n just makes negative 6i over n plus 9i squared over n squared. Alright, so we're going to break these into 3. Oh, how did that become a 2? Sorry. That was 3 over n. So we're going to break this into we can split up summations into each part separately. And we could even just bring out this negative. It doesn't really matter. So we're going to say 3 over n times the sum of negative 1 plus 3 over n plus the sum of let's kind of break this up too. So we're really gonna, well, for now I'll just rewrite it, and then I'll do what I'm just gonna do next step. Plus 3 over n times the sum of 9i squared over n squared. So the way we're gonna evaluate this is we're gonna pull out everything but the i's and figure out what to do from here. Now in this first one we don't really have any i's, but I'll just take out the negative for now. So negative 3 over n times the sum of just 1 plus, so if I take out a negative 6 over n and multiply it by 3 over n, I have negative, so I'm going to change this to minus 18 over n squared. And then I'm just left with the sum of I. My summation symbols are getting sloppier as I get tired of writing so much. And then if I take out 9 over n squared, I have 27 over n cubed I squared. Just looking at my notes too, I mean, I think when I did this problem before, and it shows you that you can do these a couple different ways. I'm looking at my notes from earlier, and when I did the problem the other day, I waited to distribute the 3 over n until the very end. So you do have a lot of options. It really doesn't matter if you distribute it through or keep it outside until the end. I'm actually not sure what the answer key did. I don't remember. All right, so let's go through. The way we evaluate a constant is just n. So this is just negative 3n over n, which is really just negative 3. The way we evaluate the sum of from I to n of I, it goes to this n squared goes to n squared plus n over 2. And then I squared is that whole n times n plus 1 times 2n plus 1 all over 6. So now we have negative 3, and then we have a lot of algebra here. Minus, I'll do it each part at a time. So we have 18n squared over 2n squared, which we can simplify, minus 18n over 2n squared, plus, I'll keep this like that for now, and I'll show you that this just makes, we've seen this from other problems I've done. If you multiply it out, trust me, it makes 2n cubed plus 3n squared plus 3n squared plus n over 6. So this is negative 3 minus 9 minus 9 over n plus, so we have 27 times 2, which is 54, and then over 6. So we really have just, I'll do it one step at a time, 54n cubed over 6n cubed plus, this is just going to be 27 times 3 over 2. I'm just going to make this a little easier and just say 27n squared, or let's say 27n squared over 2n cubed plus 27n over 6n cubed. So this is negative 12 minus 9 over n plus 9 plus 27 over 2n plus, we could actually take a 3 out of this if we want and make it 3 over 2n squared. But really all of this is, remember, this is all equal to the limit as n approaches infinity, which is how we're going to finish now, because as n approaches infinity, this goes to 0, and this goes to 0, and this goes to 0. So all we're left with is negative 12 plus 9, which means our answer is negative 3. That is what the function, this is all, we were all trying to do this to figure out from 1 to 4, this function, the integral of this function is negative 3.